Hello everyone, Nick Wynn here, and today we're going to go over the International System of Units, or SI. So what is the International System of Units? Well, it's also known as the metric system. Well, and then when we think about the International System of Units, it is a way where scholars and scientists have standardized a way of measuring things so that people all over the world will be able to measure things the same way. Pretty much all the countries in the world use the system with some notable exceptions, like the United States, which uses the English system. But basically, the metric system consists of base units with its metric prefixes. But before we get into there, we're going to go over the 7 physical base units that the metric system, oversees, in which many scientists and scholars use all over the world. So, for example, second, which is a unit of time, denoted as S. Meter, which is a unit of length, which is denoted as M. Gram, which is a unit of mass, which is denoted in G. Ampere, which is a unit of electric current, denoted as a capital A. Kelvin, which is a unit of temperature, which is denoted as a capital K. Mole, which is the amount of substance, is denoted with an MOL, which we will be learning a lot in chemistry this summer, so keep an eye out for that. And last, we have a candela, which is a unit of luminous intensity, which in layman terms, it means how bright a light is shining, which is denoted in CD. So I guess if we're thinking about things in the English system within the United States, time is the same, but meter or unit of length, we often use feet or yards or miles. So that's a unit of length that we use. Gram or unit of mass, we use pounds mostly. Sometimes we say tons. And then for temperature, we usually say Fahrenheit. But something notable about the metric system is that this also includes Celsius, which is the most commonly used form of temperature. But in terms of a Kelvin equals however many Celsius you have plus 273, which we will use this more later in the summer chemistry course. But now we're going to go over the metric prefixes, which it may seem a little daunting, but don't worry. So when we talk about, the metric prefixes, we always start with the base unit in the middle. If we go up and we up the scale, and you can see that they increase by magnitudes of 10, we have deca, hecto, kilo, mega, giga, tera, and peta. If we go down, this also goes down by magnitudes of power of 10, which of course is deci, centi, milli, micro, nano, angstrom, and pico. I'm going to erase this. So when we think about these metric prefixes, you see that there are different scales such as like 1, 10, 100, or 0.1, 0.01, etc. So what does that mean when we talk about base units? So I'm just going to give you an example first. Let's say we have 1 kilometer. That's oftentimes what you see in Europe on road signs, saying that, Paris is 30 kilometers north. So that's their version of our mile. But what is really nice about the metric system is that everything is in 10, so it makes it easier. Unlike the American system, where 12 inches is a foot, we have 3 feet in a yard, we have thousands of yards in a mile, etc. But with the metric system, everything is so much easier because everything is by the power of 10. So when we think about a kilometer, the reason why we use these magnitudes of 10 is because we'll get back to the number of base units. So in terms of kilometer, the base unit of kilometer is meter. So if we have 1 kilometer, we multiply it by this number, the scale, which is 10 to the third, or in other words, 1,000, you will get 1,000. Of course, 1 times 1,000 is 1,000. But what is really nice is that we will have 1,000 meters. So for every kilometer, there are 1,000 meters. So that's when you scale up the factor. How about when you scale down? Let's just say we have millimeters. So millimeters is oftentimes used a length for many different disciplines of science. So let's go to millimeter. So for example, we have 1 millimeter. We're right over here. If we multiply it by the scale factor, which is 10 to the third or 1,000th, you will get 0.001 meter. So what that means is that for every 1 millimeter, there is 0.001 meter. So basically, when we think about the metric prefixes, the actual distance, the actual gram number of the actual mass doesn't change. It's just a different way to view it and a different perspective to view it in terms of numbers. We're going to see that they see this in practice. So I'm going to erase this, and then we are going to go to the next slide. So we're going to do conversions now. What is 1,000 grams in kilograms? Kind of like the example that we had in the last slide. But when we think about 1,000 grams, so we know that our conversion factor, or the scale that we saw back then, was that for every 1 kilogram is equal to 1,000 grams, right? Or 10 to the third, like we saw in the last slide. So if we know that our conversion factor is for every 1 kilogram for every 1,000 grams, we can figure this out. Pretty easy, right? So when I think about doing conversions, I always like to use very standard math rules. So something to keep in mind is that if you have the same variable in a fraction like x over x, these cancel out. Keep that in mind, okay? So if we have 1,000 grams, and we know that our conversion factor is this right here, so we're going to do 1,000 grams, and then we're going to multiply, and multiply by our conversion factor. So this is going to be our conversion factor, and what I like to think about is what you want to end up with on top. What you want to end up with is going to be put on top, while what you have, or what you are given, will be in the bottom. So what we are given, or the unit is grams, we'll put grams in the bottom, and we're going to put what we want, which is kilograms, on top, right? So if we go back to our conversion factor right here, we will say that 1,000 grams is going to be for every kilogram, or 1, right? So therefore, by doing this and keeping this in mind, grams will cancel out, and you'll be left with kilograms. And therefore, 1,000 divided by 1,000 equals 1 kilogram. If we think about significant figures, these are trailing zeros with no decimal point, so this will be just 1 sig fig. Okay. Don't worry, we're going to do more practice. What is 426,654 centimeters in meters? So we first have to come up with our conversion factor first. How many centimeters is in a meter? So if we have 1 meter, right? We know that there are 100, or actually, we actually have to go scale down. So I'm going to erase this. So since we're scaling down, we're going to know that 1 meter is going to equal 100 centimeters, or 10 to the second, or in this case, it's going to be 10 to the negative second, and we know that, right? Another way to write this, in order to account for this 10 to the negative second, is going to be, for every 1 centimeter, it's equal to 0.001 meter. But just keep that in mind. We're just going to keep with this one since we're working with values greater than 1. So if we start off with this, so this is what we are given. So we're going to start off with 426,654 centimeters. And then we're going to multiply by our conversion factor. So, right? So what we want is we're going to put on top, and we want is meters. Well, what we have is going to be on the bottom, which is centimeters. So if we know that there are 100 centimeters per 1 meter, that's going to be our conversion factor. Centimeters will cancel out, and we're going to be left with meters. So I give you guys, so you can pause this video, and then I'm going to come with the answer. And what I get for the answer is going to be 4,266.54 meters. Is this the number of sig figs that we need? So this is 1, 2, 3, 4, 5, 6. 6 sig figs. And this is also 1, 2, 3, 4, 5, 6. 6 sig figs as well. We're going to keep this as our answer. Cool? Next one. So how about seconds? What is 2,400 seconds in minutes? Pretty easy, right? Instead of thinking about length or mass in the last two examples, we're going to talk about time instead. So in terms of our conversion factor, how many seconds is in a minute? Well, we know that in 1 minute equals 60 seconds, right? So that's going to be a conversion factor. So if we know that there are 2,400, keep sig figs, seconds, our conversion factor, so we multiply by 1 minute, back to keeping the minute, to 60 seconds, right? So, yet again, what we want to end up with is going to be on the top, while what we are given is going to be on the bottom, so that unit can cancel out. So we're going to do seconds, and then we're going to divide by 1 over 60, or divide by 60. So 2,400 divided by 60 is going to equal 40 minutes. But how many sig figs do we need? So this is 6 sig figs altogether, so we have to adjust our answer. So 40, 1, 2, 3, 4. That is 4 sig figs, 6 sig figs altogether, 40 minutes. So that's going to be our final answer. Okay, so if you're feeling pretty comfortable about metric to metric conversions, we're going to have English to metric conversion. So we're going on to the next one. Okay, so sometimes you're going to have to do multiple conversions within a problem, in this case, we will have to do that. So the question asks, what is 3 yards in centimeters? So we've got to first come up with our conversion factors. So for every yard, if you didn't know this, for every yard is 0.9144 meters. But they're not asking for meters. We need centimeters. So in terms of every meter, we need 100 centimeters. So these are your two conversion factors that you're going to have to use. So let's start up with what we're given. So 3.000 yards, right? We're going to multiply by conversion factor. And you want to get rid of this yards first. So we're going to do this conversion factor first. So we're going to multiply by that conversion factor. What we want in terms of length is going to be meters, right? And then what we're going to cancel out is yards. So for 1 yard, it's 0.9144 meters. But then we don't want meters in the end, we want centimeters. So we're going to add an additional conversion factor. So we have meters right here, so we want to get rid of that. So we're going to put meters in the bottom right here, and we're going to put centimeters. Thus, we're going to use this conversion factor as 100 centimeters with 1 meter. Okay? Therefore, yards will cancel out and meters will cancel out. So we're going to end up with centimeters. So we multiply 3 times 0.0 0.9144 multiplied by 100. We're going to get 274.32 centimeters. But are we done? We need sig figs, right? So this has 4 sig figs. So we have to round this. So 274.3 centimeters. And that is going to be our answer. Okay. Last example. We're going to do pounds to kilograms. So this one's just going to be a 1 conversion, which I'm going to give it to you. So for every 1 pound is going to be 0.453592 kilograms. So now we're going to do the math. So we start off with 56 pounds multiplied by a conversion factor right here. So we want kilograms, so we're going to put this in the top while what we are given is going to be in pounds. So for every 1 pound, it's going to be 0.453592 kilograms. Multiplied by that, so 56 times 0.453592, we're going to get 25.401152 kilograms. But how many sig figs this is? 2 sig figs. So therefore, this is going to be it. So altogether, 25 kilograms is going to be our final answer. So this is the last example. I hope that you guys have gained a better understanding of the metric system. If you have any questions, feel free to ask Mrs. Matthews or the 3 interns, Paul, V, or me. I hope you guys have a great day. Thank you.